Hi friends, wouldn't it be nice to have the state of charge of a battery? Of course yes, but it turned out that it is more complex than we expected. In a former experiment, we did voltage measurements over time. However, what does it really tell us about the state of charge of the battery? Most of us already know that battery state of charge is somehow dependent on the voltage, the temperature, the number of cycles and the age of the battery. In this episode we get methods and tools to calculate it. When we search the internet for battery state of charge, we find a lot of data that can be quite confusing. Since we can easily measure voltage, we first want to know the relation between voltage and state of charge. And we find data like this. Okay, we understand there is a non-linear characteristics of the voltage versus the state of charge, which makes it already a bit difficult to calculate. But wait a minute, there is also a strong dependency on the temperature. Ooh, my voltage versus state of charge diagram is only valid for 20 degrees Celsius. What if I want to use my battery outdoors at a temperature range between 40 degrees plus and minus 20 degrees? We also find some data about the temperature dependency. And we can see that there is a significant difference between the extremes. How can we tackle this? Now, to complete the mess, we need to consider the number of charging cycles and the age of the battery. Oof! This is now 4 parameters and 3 of them having a non-linear influence to the state of charge. How can we tackle this to calculate? Another cool tool is helping us here. First to do the state of charge calculation and then to understand the rationale behind and the coding. Of course we want to have fun with our project, and instead of making you nervous now with the complicated math behind, we want first use the tool and then understand the calculation. You can use it straight away. The inputs are pretty easy. We start with the battery temperature. Let's assume that it is 30 degrees of Celsius, which might be just after charging. The tool is giving us immediately the voltage for the maximum state of charge. We insert this for the actual voltage and voila, it says that the charge is about 100%. We can play now with any other voltage or temperature. With 3.5 volts we would have about 24% of charge, and with 3 volts the battery would be practically empty. Let's make an expert calculation now. From an earlier episode's energy flow calculation, we know that we need a battery of minimum 2000 mAh for an outdoor sensor. We want to dimension now a battery that overcomes 5 years operation. 2000 mAh shall be our 100% charge now. The minimum temperature shall be 0 degrees Celsius. Inserting the 0 degrees Celsius, we can see immediately that this is giving us a drawback to about 83%. We know that our consumption is about 150 mAh per day, which means that we have about 140 full charge cycles in 5 years, what we can find out with an easy calculation. The result of our calculation shows us now that after 5 years the maximum charge of the battery is only 67%. This means that if we want to guarantee the 5 years of operation, we need to dimension the battery about 33% bigger. We knew before that we have to overdimension it a bit. However, now we have some tangible figures. As promised, I want to explain now some secrets of the tool that may allow you to adjust the tool to any other battery type instead of lithium-ion. In the tool, we are using a so-called functional approximation of the discrete values that we got here highlighted in blue. The graphics is showing us the fit between the discrete values and the function that we found, applying the parameters in the upper section of this picture. This method is then also applied to all the other nonlinear characteristics that we were talking about, so that we can compute the state of charge for arbitrary inputs. In one of the coming episodes, we will explain this functional approximation and how you can derive code and constants for your own programs from it. We applied this already in an earlier experiment. I want to explain now where to find it. Our tools sometimes have some hidden Easter eggs, like this one. We applied this method here to calculate the state of charge of the batteries that we were observing. And on the top here you find the parameters that have been used for this. What are the learnings of this episode? Batteries have a reversible characteristics that is depending on voltage and temperature. And they have an irreversible characteristics that is practically degradation over time and cycles. Our tool is able to predict all these effects for batteries dimensioning. Absolute battery experts may forgive me for the simplifications that I made in the tool, because I know they would know a lot more effects to consider. For us hobbyists, the tool should do the job. Hope you enjoyed the video and you're having fun with the tool. You can download as always in the download section. Now stay tuned and don't forget to subscribe and support the channel. See you soon in the coming episodes.